All right, hey, what's up here? Mr. Fortin here. Unfortunately, you can't see me on video because for whatever reason, what I'm using to record this isn't accessing my webcam. Anyways, I'm gonna go through this because I got this email. Check it out over here. Hi, Mr. Fortin. I don't know how to solve the system of equations in 788 Part B. Can you help me with what steps I need to follow to find the values? Okay, we need to get that A, that starting number. We need to get that B, the multiplier. And here we have 2 points. I might actually just write that one down. We have 2 points down here. We have the point 218, right? Because this is, the y equals a times b to the x power, right? This is kind of one of these exponential functions we've been dealing with recently. And then here we have y equals a times b to the x power here. So we got 1 point and we have a second point, 354. Now we're going to have another day of curve fitting. That's right, curve fitting, another curve fitting lesson. We'll do that on Thursday. And yeah, given 2 points, you can figure out what the exponential function would be, right? So this one here, it's going off a little bit side note here, but this one here, if I were to actually get some axes down here, let's actually get some axes x, y. What this one would look like would be like, 1, 2, maybe go by like 20, 40, 60. Let's put 60 here. I'd have a point at 354 or so. And I'd have a point at 218 or so. Okay, right? And this would look like this guy, that curve right there. Right, if I put this one, 2, 3, right, 354 or so, 218. Okay, so anyways, you don't have to worry about graphing or anything like that. But if we're talking about, knowing that this is kind of an equation here with a certain multiplier, a certain starting number. Oh, we got to figure out what that starting number is. Got to figure out what the multiplier is. That's going to deliver us a graph like this, and that's what this is all about. Okay, so given these 2 points, how can I solve for A, solve for B, and get it so that I can determine what the equation, the exponential function equation would be. Okay, so let's go ahead and take through it here. That was kind of a long-winded beginning. Okay, a few different ways you can solve it on this one. I've seen a lot of creative solutions so far, but my recommendation here is step number one. Okay, step number one here is what I would do is isolate A on both equations. Isolate A. Okay, so I have A here. How can I get A isolated? Well, I got to get rid of this B squared. It's being multiplied. What's the opposite of multiplication? Divide. Okay, divide. So I divide both sides by B squared. That's what I'll do in this top one. Here, I got A. How do I get A by itself? I'm going to divide both sides by B cubed. Then I'd have A by itself. Okay, because after I get A isolated on both equations, number two, what I'm going to do is I'm going to use equal values method. The equal values method to solve for B. Okay, to solve for B. That's what I'm going to do on this one here. Okay, right? And I'm kind of giving you some guidance, and I'll do it along with you right here. If we don't remember what equal values method is, we'll go over it. Okay, but the idea is if I get A isolated on both, I have two expressions that equal A. So I can set those two expressions equal to each other. Okay, you'll see when we kind of go through it. Step number three is what we do once we have B. Well, you guessed it. Okay, what I'm going to do is I'm going to plug in B to one equation and solve for A. Okay, and I'll be good to go. All right, so let's actually do this here. Like those are sort of the steps that I'm going to follow as I go through this. See if you can kind of follow along. Okay, first thing I'm going to do is maybe I'll do it in this bottom one because I have a little bit more space. I'm going to isolate A. Okay, right? I'm going to isolate A because if I can get A equal to something, I can either substitute. I can use substitution method, but I think I'm just going to do an equal values method. If I can isolate A, then I have an expression for what A is equal to in this equation. I can isolate A up here and get a different expression that A is equal to, and I can use that to solve for B. We'll do that in a second here. Okay, so to get rid of this B cubed, I'm going to divide this side by B to the third power. What's my math rule? If I divide one side by something, I got to divide the other side by the same amount to keep my equation balanced. Okay, so remember, solving is involving doing the opposite, right? To cancel that out. Okay, and I can bring this down. I can divide this by a factor of B to the third power as long as I divide this side by the factor of B cubed here. Okay, so now I have A isolated. Okay, that's it here, right? I cancel this all out. B to the third power divided by B to the third power is 1. So I got 1A over here, and what is it equal to? The one expression that I have for it is 54 divided by whatever B to the third power is, right? Because if I had to multiply b to the third power to get to 54, I'd have to divide by b to the third power to get this down to a, okay? So I have that. I'm going to do it on the top equation too. I don't have much space. Maybe I can pull it over here. Okay, I'll put it over here. I got 18 equals a times by b squared. I'm going to isolate a. Okay, another thing I could note here too, one thing you could do, which I'm just not going to do in this video, is now that I have a isolated, I could actually substitute for a, I could substitute 54 over b cubed. And that might be a way to get there, okay? But I'm not going to do that for the sake of this video, just because I think equal values method is speaking to me right now. All right, so I have this. What can I do? Well, I can divide both sides by b squared, and then I have another expression. Check it out. B squared divided by b squared cancels, right? That makes a 1. B squared divided by b squared is 1, so it'll be left with 1 times by a, or just a here. So I'm left with this. A is equal to 18 over b squared, okay? So I know this is an expression that's valid for a. I know this expression is valid for a. So what I'm going to do, right? So I isolated a on both equations. Now I'm going to use equal values method to solve for b, okay? Because a equals this. A also equals this. And this is something called the transitive property in geometry. But if you have one thing and one thing here that is equal to two different things, then those two different things must be equal to each other. Why? Well, 18 over b squared is equal to a, right? Well, what else is a equal to? A is equal to 54 over b cubed. Ooh, and this gets a little nasty here, okay? So now we got something, I've been doing this a lot in geometry. This is called a proportion. A ratio equal to another ratio here. And you have b cubed in the denominator. Ooh, I got to get b. This is a little bit hard. So what you can possibly do, a valid rule here that's going to get you to the finish line with getting b, or close to the finish line, is this. Okay, but the problem is I got my b squared in the denominator, my b cubed in the denominator. What I'd recommend to you is potentially to move things to the numerator. I can multiply both sides by, right, when you have a variable in the denominator, just multiply both sides by that variable. And I'm multiplying by b cubed because I can get b cubed divided by b cubed is 1. So on the right side of this equation, I have 54. And on the left side of this equation, well, this is simply, right, this is simply b cubed times by 18. All over b squared, right? That kind of thing here. So I have 2 times b times b up here times b, right? 3 times in a row, and b times b down below. So 2 of these b's is going to cancel out 2 of the b's on top, okay, right? B to the third power divided by b to the second power will just be b to the first power. 3 minus 2 is 1. Okay, so I'm on the left side here, I have, because, right, that goes away, I have 18b on the left side here. 18b. And I found my multiplier. Check it out. There's only one thing I need to do to get my multiplier. Kind of a lot going on. It's a challenging problem, but there are different ways to get there. Divide both sides by 18, and I get b equal to 3. So there's b. Okay, there's b. I got it. I solved for b. Hooray! I feel great about that. Now I need to plug in b to one equation and solve for a. Well, I could do that either on the top equation or I can do it on the bottom equation. Which one's going to be easier? Well, I have a smaller exponent up here. So my guess is that this is going to be a more simple equation to use here. Okay, so step number 3, let's go ahead and do it now. I'm going to bring it down here, plug in b to solve. It's one equation to solve it. I'm going to use this one, right? I'm going to use this one up here. So 18 equals a times by, well, I did all this work. I got b equal to 3. 3 squared, and yes, I think we're going to see this come together very quickly. 18 equals a, and then 3 squared is 9. So 8 times by 9, well, what do I do to get rid of the 9? Well, for multiplying, the opposite of multiplying is division. So divide both sides by 9, and they get 2 equals a. And there it is. I solved my system. And because, right, the idea of this is that, you know, what we'll do in curve fitting class on Thursday is that I got 2 points. Once I get a, once I get b, I can actually write the equation of the exponential function that goes through those 2 particular points. And I got that intelligence for me here because, hey, we worked it on out. Thank you for the question. Hopefully, if you find an easier way and want to share it with the class, feel free to shoot a video or something like that over, because there are some other ways to do this one. Message me if you have any questions. Thanks for watching. Bye.